All right, it is the top of the hour. It's time to get started. Welcome to the TLS working group. We are the last session of the day and of the meeting itself. Joe, can you go to the next slide? All right, here's the IETF note well. Hopefully you've seen this and know it well. It's about policies and procedures for acting and participating in the IETF. You can scan that QR code there to get more information if you would like. If you have any questions, you can ask the chairs. You can ask the ADs, who's Deb now from Paul. If you feel like there's been any issues, you can again come to us or you can go directly to the Buds team. Thank you. Next. All right, meeting tips. We are going to use the queue, so make sure that you queue up properly. So obviously you've got to be logged in, but go ahead and use the join the queue so that we can get you in. Please make sure to state your name and affiliation when you get to the microphone. I know I usually don't. I forget to do that as well. I'm Sean. Joe's there as well. I think Deirdre, she might be here, but I think she's at the airport. All right, next. Monday agenda. I think we can skip past this. Friday agenda. We're going to spend a lot of time, or we allocated a lot of time to talk about extended key update. We have a document. It's been progressing along pretty well. We got some FAT review, and we're going to go through that. And I think then Yaroslav, who is local to this session in Shenzhen, is going to present a little bit. And then we have some non-working group IDs that we're going to go through. And I know that we also have some measurement data for ECH stuff, which will be interesting to review. Are there any agenda bashes? All right, going once, going twice. That's good. We're also going to we're going to jump back to some share slides because there were some things that we had open. Sorry, Tom, did you want to? We got some share status stuff we're going to do a little bit first. Do some cleanup here. So if you can get to the keep going. We did that one. We did that one. We did that one. So breaking news. All right, third time's the charm here. We had a suggestion to prohibit key reuse within RFC 8446 and RFC 846 bis because currently now we do not forbid the reuse of ephemeral keys. In the current version of 8446 bis, we did add some text about should not in Appendix C, but we've got a renewed push to go ahead and make that prohibition more permanent and move it to the main body. Ecker has a PR that he's already submitted, and there's already been a bit of a thread on this with a lot of people that have participated. So I just want to make sure that we also highlight that there's been a concern that that this is just kind of a feel-good change, and implementations do and will continue to do this. But we seem to have a lot of people that are now interested in making this change, so we're going to go ahead and do that. Yeah, Nick, I know that Dennis is going to go ahead and give the presentation. So we're going to do another consensus call to try to change this point. I guess what I have got that message ready to go. I will send it probably Monday to give everybody a chance to chill. It'll be the typical 2-week thing. But I guess what I want to say is, since a lot of people have already responded in the thread already, if you don't feel like you don't need to repeat yourself in the thread if when we kick it off again. All right, next. All right, so we also got 2 liaison statements. This one I want to talk about. There was another one from the ITU about using QKD with TLS. We'll let that one sit. But this was the one from the IEEE where it has not yet hit the IETF liaison statements page. So we'll provide a link. That link will update when it finally gets updated. I believe it's been forwarded already, so it'll probably happen when the Secretariat gets back to California. But the basic idea is the IEEE working group would like to express support for publication of the Pure ML Chem document as an RFC with its definition of key establishment options that use Pure ML Chem. They also would like the EAP group to do some stuff, but this is just basically kind of like I'm just giving you a heads up. All right, next. All right, this is an update on our ML Chem ID working group summary. So Joe and I have reviewed all the messages, all 198 of them, or 235. I can't remember which number was in which time we did it. So just a little scolding here from the chairs. When we ask you if you support or do not support progressing a document or adopting a document, it would really help if you would actually put that phrase, I support or I do not support, in the message. We're not trying to read tea leaves. We need you to be pretty explicit about that. And so basically what we've got at the point is that we do not believe we have consensus without resolving the following points. To deal with key reefs, which, see the first slide I talked about. Text for preferring hybrids. I believe Deirdre was in the process of trying to put some text up to see maybe if we can get some agreement on that, and whether or not to include some motivations. And if we were to do that, obviously we could refer to the liaison statement that happened on the slide that I just talked about. So we don't think that this is going to happen really quick, but we think it's going to take a couple of weeks, and then we're going to try to run a targeted last call to see if those changes can help us get over to the point where we do actually have consensus. Does anyone have any questions about this? I want to apologize for us taking so long to get to it. Muhammad?
Yeah, somewhat your question. So it still doesn't address the concern that I have going from hybrids over to the pure amalgam, the security properties that you lose. I don't see that anywhere in any of the 3 points that you have mentioned here. So can you elaborate on that, please?
Sure. My understanding from reading the list, because I'm not a cryptographer, is that chems in TLS are actually quite well understood at this point. And my understanding, or the tea leaves that I've read, is that we would be okay to proceed forward. You may not agree, but that's what I heard.
Yeah, I mean, I would completely disagree. So the thing is that you have two different hard problems in hybrids. And that is to say, if one breaks, the other one will still protect you. And that's the property that I don't see happening in the pure amalgams. And that's really something that I'm worried about. And what I proposed in the last meeting was that this should go over to CFRG or FAT, or maybe something like we need some proper guarantees for this in order to put it in. I mean, just thinking from the top of the head that, oh, this actually looks good or something like that is not something that I can actually put trust in. So I would appreciate that if we have a proper analysis of this before going into putting it into the TLS itself. Thanks.
Okay, so I don't want this to turn into a litigation of the working group last call. I see a lot of people that actually are cryptographers are in line. So I'm going to go ahead and close the queue. We're obviously going to take weeks to go over this. If we need to add another point, we will. But I'll try to see if I can figure out where the lock the queue thing is. So thank you very much. Go ahead, John.
Yeah, I think it would be good to take this key reuse first, because if TLS 103 forbids key reuse, all my major issues with this draft disappear. I think most of the formal verification issues goes away also. So I think fix that first and then discuss this.
Tanya?
Yeah, so I think there's some very principled reasons missing here, but I agree that those principled reasons will not be easily removable. I mean, if your statement with a slide is you want to try these and then see whether the concerns go away, I agree that saying people are concerned about security is not one that will go away. But I think there are several of us who expressed concerns similar to what Mohammed has just been expressing, and those are not being addressed by this. And I would appreciate if at least you could state that you have read that there are people who say, no, we are not ready for exposing the pure, exposing the new systems which are less well understood, less well implemented, as a sole security guarantee.
Thanks. Tom?
Yeah, basically my question is, maybe let's first comment on my webcam is totally freaking out, so let's quickly turn that off. distracted now. The FAT is not set up to evaluate the security properties of chems and elliptic curve schemes or any sort of cryptographic primitive. We're a bunch of protocol experts, not people that look at the security of cryptographic primitives. Aside from that, I believe that the point does stand that chems are understood very well, and the way that chems interact with TLS is understood very well. But evaluating the core SVP security or whatever of MLChem is definitely not in scope of what we're doing. Nor do I think that CFRG is really qualified to do any of that. That's years and years and years of publications in conferences. I guess CFRG could maybe be asked to make a summary of that, but even that would be probably pretty tough. I think it's fine to say that NIST has done that work already. The question I had to the chairs is targeted consensus call. Does that explicitly mean that we're going to, aside from the bashing that will surely happen on every comma in the text for preferring hybrids, does this mean that we're going to put the concern a non-hybrid is a non-hybrid aside? That's lots of people were voicing.
Yeah, I think you got me on that one.
I mean, the targeted means we're targeting at the changes that we're making in response to these points.
These 3 points, okay, because I do agree with the other stat. The point of we don't like non-hybrids because they're non-hybrids was also raised a lot.
I think
don't
that
necessarily agree that that is something that should block this document. But that is what we will see a lot of again in the any next working group last call on this. And I think Ecker also sort of asked, are we going to be explicit about how we're going to go forward with this?
Yeah. So we'll work out the details of the call, exactly how we'll state it. But we know that there are people who are for and there are people who are against, and they've voiced their opinion. And then there are people who may change their mind for better or for worse, depending on how the text turns out. So that based on that, we will then be able to close out the consensus and see if we have a rough consensus or not to move forward.
Okay, thanks.
Thanks, Tom. Victor?
Yeah, I thought that the second bullet sort of largely tries to tackle the issue that the previous statements were discussing, in that if the security considerations clearly outline the risks of why you might want to use a hybrid and essentially put it as the risk-averse choice that you should do when you don't have better reasons to do something else, that should address the comments from Usama and from Tanya and so on, by clearly saying use hybrids unless you know better. In terms of realities on the ground, OpenSSL supports pure MLChem and will continue to support pure MLChem. It's just not on by default. A user can turn it on if they want it. But that's not going to change no matter what this draft says. So I don't know what we're arguing about exactly, frankly.
Fair enough. All right. That's kind of the heads up. Again, wait for the message, and we'll try to get through it. Okay, I think we can release this queue, and we'll go over to Tom. And I'm going to set a timer once I figure out how much time I think I agreed to give him and everybody. So I'll put all this together in one time bucket. All right, 25 minutes.
Would like control as well, please. Great. And a different webcam, so it's not freaking out anymore. So yeah, I asked to give the summary of the discussion of the formal analysis triage team, who were asked to have an opinion about the draft that proposes extended key update for TLS 1.3. Getting into this, I'm basically going to explain a little bit of how you write a proof, which might seem a little bit like, where are you going with this? I believe that it will help make sense of why certain things are more difficult, even though they seem very easy up front. So if you look at TLS 1.3, we basically have this sort of two phases in the protocol. We first have the chem key exchange, or classically the ephemeral Diffie-Hellman key exchange, and we can say properties about that, like this is secure against passive adversaries. If nobody messed with the chem key exchange, this will remain secure. And then once you do all of the signatures in the handshake, you get out the session key, and then we like to say that that has properties like secure against active adversaries. So even if someone messed with the ephemeral key exchange, they got kicked out because they don't have the key that they need to produce the signature, and thus it's secure against active adversaries. Then we can layer the fancier stuff on top of that, like forward secrecy, which you could phrase as like the session key is hidden from the adversary if they don't know the ephemeral keys, or they didn't know the signature keys when the session key is established, which implies properties like even if we do give the adversary the signing keys, if we do that after the session key is established, that key remains hidden. This is how we write these things in the models, and coming up with the right phrasings of all these properties is a lot of work, but that is how the proof sort of proceeds. Then we sort of have the existing mechanism in TLS 1.3, which is the non-extended key update. That mechanism is essentially you run a KDF, so key derivation function, or in other words, a hash, fancy hash. You run that over the existing session key, and then you derive a sort of next session key. And I'm actually not sure if this has been covered in any of the proofs, certainly not any of the pen and paper ones that I'm aware of. But if I would want to write a proof for this, I can sort of look at the existing models and then add something that says something like, if we add session key 2 to the attacker, then even if session key 2 is leaked, all of the stuff in the past, so session key 1 remains hidden from the adversary. So this is a forward secrecy property again. So yeah, like I said, I can sort of build on the existing model, and because I already have a proof of security for session key 1, and I'm not revealing session key 1 because that remaining secret was the whole point, I can make a lot of assumptions in my proof, and that makes life a lot easier. I don't need to worry about any sort of malicious key update because the adversary can't interact with that. I can continue what I've proven in prior stages because that makes sense. And all of that makes, if you would want to add this, fairly straightforward. We're sort of leading into the fact that this is a little bit more difficult for the extended key update draft. For extended key update, we're actually doing an ephemeral key exchange. So this is about kicking out an adversary from a prior bad state and then recovering security, if we want to consider post-compromise security. So if we give session key 1 to the adversary, so the previously established key, and the extended key update mechanism is able to execute without interference, then session key 2, which will then newly be generated from this ephemeral key exchange, will remain hidden from the adversary. This is the definition of post-compromise security, but you're already sort of noting that there's a lot different here. Because it's about recovering security, we are suddenly breaking lots of tradition with the model that we had before. So we need to leak the previously proven confidential and authentic session key 1 to the adversary, because it's about recovering security even if the adversary got these keys, which means that I need to worry about malicious extended key update, what that means, how I write that down in my model. I probably need to invent new adversaries. The adversary that needs to be passive only after being active before, and that's a little bit funky. And I can't necessarily continue to reuse what I've proven in prior stages, because the adversary gets to play around with the session key for a while. And doing all of that makes life quite a lot harder when you want to write a proof for this, or design a model that captures the security for extended key updates. There's some related work, because I do agree that this mechanism is not necessarily new or particularly exciting. The proposed mechanism for extended key update resembles continuous key agreement as found in, for example, Signal. You might say we have lots of proofs for Signal, but unfortunately we don't really actually have a proof that links the key exchange in Signal cleanly to the continuous key agreement. So that's actually also a gap there. And in IKV2, there's a mechanism for security association rekeying, the create child assay rekeying of the IKE assay, which for extra fun supports complete renegotiation of absolutely everything without any authentication. But there is no analysis of that I am aware of, and I've been looking at that for a while now. So there are other mechanisms, but unfortunately we can't really lift any of the analysis from that to this case cleanly. So where are we? I have to say all of the interaction with the draft authors was very pleasant. I do agree that the main thing that they're proposing is sort of very simple. There were some confusions on forward secrecy and post-compromise security in very early versions of the draft that haven't been resolved. But there does remain some sort of subtle trickery and lots of potential for subtle issues in, for example, the key computation. And I do again want to say that we all acknowledge that the authors have put in a lot of honest effort and are very motivated to get to the bottom of this, which is also very good to see. The text here is a little bit small, unfortunately, due to the technical detail, but what you're seeing on the left hand of the slide here is an abstract is extracted from the key computation in the extended key update draft in a prior version, because it's fixed now. But it used to be that they, for very practical and reasonable reasons, had decided, okay, when we're going to rederive a new secret, the extended key update draft rotates the main secret as it goes forward, instead of only the client and server traffic encryption keys. When it's rotating the secret and then it derives the new application traffic keys, it's what TLS 1.3 does is without extended key update is that it includes the whole transcript of all of the messages that have been sent to compute that key. But because keeping track of all of the different things that could happen after the handshake, they decided to simplify this to only include the 2 messages that were exchanged during the actual extended key update that happened. This unfortunately meant that because the traffic keys are, the main secret actually contains no information on the transcript in TLS 1.3, that meant that you actually were unlinking the newly derived keys from the existing TLS 1.3 key schedule. I'm not saying that this is necessarily insecure, but certainly it would have made arguing that you're not deriving new keys in a way that is unsafe. Proving that might well have been a lot harder if not they had started tying the key derivation to the existing transcript again. There was some discussion on the list and on the pull request on the side effects that this has, because you need to now keep track of where everything is going, etc. If you're interested in that, I recommend looking at that. But even though this issue is now fixed, I think that this is illustrative of the kinds of subtlety that can hide in a change that seems sort of simple. So yeah, some other things that the FAT brought up, on partially on some older versions. So to continue with the theme of that, this change does touch lots of individual parts of TLS1.3 in subtle ways. Eckhard, do you want to ask a question now or at the end?
Well, I wanted to ask a question about this first quote, actually. So happy to do that whenever you want, but I want to ask a question on this quote, this first quote.
Okay, let me read out the quote and what I have to say about it, and then I'll get
Sounds
to the
good.
questions. So one of those things that has many of these subtleties is that session tickets. How are you going to deal with those if you have extended key update? Because session tickets get derived from the main secret, and extended key update is in some way about moving forward the main secret in time. So you probably want to throw away all of these old session tickets every time that you do this extended key update. Of course, managing all of that, very complicated again. And those sorts of things do require very careful consideration. And also on this issue, the authors have recently revved the text in the draft to close some gaps and recommend that you do need to throw away all of the old session tickets every time you do extended key updates, which now give the floor to Eckhard.
So is your assumption here that the long-term keys are uncompromised?
Yes. So in post-compromise security, you are not re-authenticating, or at least in extended key updates, or in like what you're doing in Signal, you're not doing new exchanges with the identity keys, so the signature keys, or in the case of Signal, Diffie-Hellman identity keys. The only thing that you're assuming is you want to recover from a situation where, for some reason, the keys got leaked. I guess that for this draft, that might be because maybe they got, you're doing kernel TLS or whatever, and the traffic keys got leaked from the network card. And then you somehow do a software update, so you kick out that adversary, and then you do uninterrupted and unobserved a new ephemeral key exchange.
Right. I guess the point I was trying to make here is that, from TLS's perspective, each session is each connection is a new thing, and so if the authentication keys are compromised, then you could just reinitiate a new session with authentication keys, and the situation is no different from the session ticket is taking the place of the authentication keys, right? I agree with you that if you want to that you need to remove the session tickets, but only makes sense if only the traffic keys are compromised, because if the authentication keys and the traffic keys are both compromised, then the situation is the same as the session tickets, because the session ticket is effectively the authentication key.
Yeah, now I think that you're sort of capturing the subtlety here, is that indeed we're from the ephemeral key exchange and the sort of internal secret state of the handshake, you are minting new authentication tokens in some way that you could carry over into the next connection. So if we don't throw away old session keys, you can sort of roll back and use these session tickets as a way to bootstrap.
Right, but for instance, you could say you stored the session keys in the same secure storage as you stored the authentication keys. Then my point is the session keys. I think we're in agreement. The session keys are like our placement for the authentication keys, right?
Yeah.
And okay. So I think that would be probably whenever we write this, that would probably be helpful to explain it that way. Because I think otherwise people might. And there's a bunch back and forth on one of these issues as well about it's like really very. It's not the draft asserts this, but it's really not the case that the authentication keys are typically stored in secure storage. They're typically stored on disk or in memory, in exactly the same. In software implementation, exactly the same place as the traffic keys. And so it's not really the case that that's incredibly common to have. It's not. There are settings, as you suggest, where it's possible to compromise one, not the other, but it's not generally the case that is true.
Yeah. I am going to punt that to the authors because that's not what we looked at.
Fair enough.
That
Fair
part
enough.
of the draft. I do also want to note that the discussion on this session key issue covered a lot of this. Yeah, it does actually matter where the session tickets keys live and all of that as well. So I think it might have gotten merged already, but that doesn't mean that you can't merge a new PR or continue discussion on a merged PR and things like that. And I think that the authors are interested in continuing that discussion as well.
Sounds good. Thank you.
Tiru, as one of the authors, did you want to weigh in a little bit?
Yes, thanks, Tom, for that raising this important issue, right? I mean, in the updated draft, right, I think Yaroslav is going to present in the next few minutes, and we have anticipated two threat models. One is where your session keys and your tickets, the key material derived for tickets is stored in different locations, and one is secure. So that threat model is also discussed, and the threat model where both of them are stored in the same location and both could be compromised. So we have now mitigations and what to do for both the ones there. So that's what Yaroslav is going to present in the next few minutes.
Okay, thank you. Let's not continue the discussion on this particular point at this time because it's probably better to just get to the end of this and then have the other things. Okay, I think that the second quote on this slide, this proposal changes the security of quote unquote normal TLS in some way, and that means that the security considerations will need to be updated post some analysis to reflect what you need to do if you implement this draft. Essentially captures our conclusion, which I'm getting to now, and that is that we do think that it is worth doing careful analysis of this extending TLS 1.3 with continuous key agreement. The existing analysis don't extend easily to this new extensions mechanisms, and symbolic analysis or computational analysis could either be helpful. And I think that we would like to see someone, and I believe that there's work in progress, do an analysis of this draft and present sort of their outcome and how they model things, and then we can sort of make a determination if that satisfies our appetite for analysis. I do want to state again that the FAT basically is just a bunch of volunteers from academia that give feedback to the working group on best effort basis and do not appreciate getting roped into flame wars. The FAT has also not done a proper security analysis or any sort of proof. And also, we can't give you a clear list of requirements of you need to do exactly this, because doing that is like 60 or 70% of the work of actually writing a proof. We're not saying that the work by the authors is not good enough. I believe that we've had very useful discussions with them, and they are trying very hard to get this buttoned down because they also want this to be secure. And finally, the FAT is not a gatekeeper for the TLS working group. We're not formally part of this whole consensus process. We're just sort of here to help inform the working group when it's going into this discussion. And finally, we fully acknowledge that just get a proof done is a very difficult thing to ask someone, because that means that often lots of work. And we really need to appreciate the work that people put in when they submit that to the working group, because they probably put in at least a few weeks, if not more time into that every time someone shows up with some sort of proof. Okay, so that is it for the FAT. And now, as the last line says, it's up to the TLS working group again. I think it makes sense to first maybe, well, actually, the authors of the draft have basically already responded a little bit through Tiru's comments just now. So I can answer one or two questions on this, and then let's give it to the authors.
Sounds great. Usama?
Yeah, first I want to really thank the FAT for doing all this work, and I think it's really useful input, and it's very valuable from the experiences. I basically want to draw attention to a specific point, which is namely the model that Thiru was mentioning. When we use TEEs, one of the concerns is that, as the authors mention in the draft currently, is that the TEE has no application traffic secret. So all the TLS key schedule is outside of the TEE. And then my concern is that basically what is the purpose that the TE is actually serving by just keeping that private key. It's not the way we use actually the TEs. You are using the whole TE just to protect a single key, which is namely the private key of the TLS, and no other key of the whole key schedule, which means that the application traffic key is available to the OS, which can be malicious, which can be perky and all that. That's not the way we use actually the TEs. So
Mohammed, let me interrupt you
yeah,
for a little bit.
sure.
TEs are completely out of scope of any of the things that I talked about. They are a deployment model, and they are very certainly valuable in interpreting the results of an analysis and how they sort of map to practical attacks. But for the purposes of modeling the security of TLS 1.3 or TLS 1.3 with such a continuous key agreement, I don't believe that TEs are relevant to the things that I just discussed.
Okay, so the FAT has not considered TEs. That's what I will summarize,
Absolutely
correct?
not.
Okay,
Absolutely
thank you
not.
very much. Thanks.
I'm not saying that they're not relevant. They're just not part of this kind of analysis usually.
All right, Victor.
Sure. You speak of discarding session tickets. I'd like a little bit more clarity about that. Do both sides have to somehow discard the session tickets? Is it only the client that discards them? Can you elaborate on that a little bit? Because servers are stateless, kind of that's the point of session tickets. So it's not exactly easy for a server to discard something it doesn't have. If it gets rid of its decryption key, then it affects lots of other clients. I'm trying to figure out what's going on here.
Since the session ticket has sort of symmetric properties, not just in the symmetric key nature, but also in the way that it can be used by either side. Yeah, it would need, if you want to throw away prior session tickets, you need to throw away all prior session tickets on either side.
Not exactly doable, right? If it's stateless, right?
I'm not saying that this is easy. I mean, one solution could be to just disable session tickets entirely if you're using extended key update. But Thiru is here to maybe weigh in because he's thought about this a bit more.
Yeah, that raises a very important point, right? I mean, right, who should discard that, right? And what we did in the current draft is that we are saying like, if you are storing your tickets, right, and then you do an EKU, right, then pretty much basically, if you are relying on the session tickets, you end up basically relying on keying material which was compromised a priori, right? So so whoever has the capability to delete them, or else best, if you cannot store them securely, right, disable the session tickets totally. I think that was something that we discussed quite a bit in the GitHub repo, I believe.
Maybe it's worth handing things over to the authors at this point if we're going to go into this level of detail on specific changes.
That's probably right.
Okay, I can get a line. I can make this point later.
Yeah, I
Appreciate
think
it.
these points are already going to be covered in the next slide, so I think we can have a good discussion at that time. Thanks.
Awesome.
Sounds good to
Joe,
me.
thank you very much, Tom. I appreciate all the work that you and the other fat people have done, and as well as your warnings and reminders, because it is true that it's not great to get sucked into some of the flame war stuff. Joe, great. Okay, Yaroslav, it's up to you. Go ahead.
Hello. Great. Right. So I have 30 seconds to present quite a few slides. Let's see how that goes. I would like to present updates to extended key update. We've done quite a bit of work before. First of all, I would like to acknowledge collaboration with Tom. So that was really great. So it was very calm, mutually respectful communication, very productive. So yeah. Kudos to Tom and FAT team. I will not cover the foundation, what we're doing and why. So what we have done since the last revision, we've updated terminology. So thanks, Usama, for highlighting some of the issues that we have in the terminology. Now things are much clearer. Then thanks to a suggestion from David Benjamin, we actually reduced a number of flights in the extended key update process. So for example, in the TLS, previous process was request, response, and then sharing the first key share, sharing the second key share, switching to the new secrets. Request with key share, response with key share, then acknowledging the response and switching on the sender, on the initiator side, and then switching on the receiver side. One message was not really necessary. We could start switching to the new secrets from the receiver side once we sent immediately after we sent the response, which we now do in TLS and DTLS. So the whole process is now having fewer backwards and forwards and is taking less time. Based on feedback from Tom, we have added transcript into initial transcript into the new transcript hash that we're calculating. Previously, we were calculating similarly to how exported authenticators do that, transcript just based on key update request and key update response. And now we are including previous transcript. And the transcript 0 is the original TLS handshake transcript that starts from client hello and goes all the way to client finished. So that way we have rolling transcript that that's beginning from the very start, and apparently that is better for the security analysis properties of this proposal. Then we have updated exporter considerations. Of course, we cannot update initial exporter secret, and initial exporter secret could be subject to compromise even after EQU. It is initial. So extended key update results in new exporter secret. And now you have a choice depending on your capabilities and your requirements. You could keep using initial exporter secret, or you should be using, if possible, the updated exporter secret. So the TLS, DTLS library might need to notify application about exporter rotation so that application would act accordingly. Along those lines, we now edit an update to exported authenticator RFC to use exporter secrets updated by extended key update. And exported, I'll talk a little bit about this later, but we now say that exported authenticators can be used to re-authenticate after extended key update, or post-handshake authentication, if it's allowed and enabled, can be used to re-authenticate the client after extended key update. We've clarified effects on resumption, and based on previous discussion, there is more work that we need to do here. So compromise of pre-shared key obtained via new session ticket prior to extended key update allows attacker to resume the session after extended key update. So endpoints must either, well, disable resumption, which is unfortunate, but could be valid compromise for certain deployments that have long-lasting sessions. That's where extended key update is typically required. Protect pre-shared keys using secure storage or isolation, or have a mechanism that would allow them to invalidate old tickets after extended key update happened, so that attacker would not be able to roll back to old traffic secrets after resumption. Edit informal security goals, post-compromise security, key freshness, elimination of standard key update, detection of divergent key state. Because we're now updating transcript, we now have a potential clash with post-handshake authentication. Yes, post-handshake authentication is a little bit exotic these days. It's explicitly prohibited with HTTP2 and QUIC, but still part of TLS standard. So if extended key update is initiated when post-handshake authentication or exported authentication is in progress, then extended key update must complete first, and then post-handshake authentication or exported authentication should be performed using new keys. Finally, we have two prototype implementations. One that I've built on top of Rust TLS that is using the new updated transcript, and Hannah's built on one on embed TLS. Not sure if that's open source. Surprisingly enough, they happen to interop, and we would like to do more interop tests. So if you have a TLS implementation and you would like to implement this and interrupt, please do let us know. And also Hannah's added Pomelo spin models to the repo. Please take a look if you're interested. We have right now two open issues. Not sure if we have time and desire to discuss them now, but would be great. So first is stronger post-compromise security issue opened by Yaron. So the question is, should we add some kind of built-in mandatory re-authentication after extended key update? So again, the risk here is if after extended key update, if attacker managed to replace the victim, extended key update would not stop attacker from impersonating the victim if it could complete extended key update if it compromised. So re-authentication could potentially prevent this. Should we add some sort of mandatory re-authentication here, or point like we do today to post-handshake authentication or exported authentication, or let it be some maybe future work? So I think right now authors believe that we should leave that aside and allow this to be explored in future work if there is appetite for that. Eric, would you like to make a comment, ask a question?
I was going to weigh in on both these points. I'm happy to do that whenever you please.
Sorry?
I was going to weigh in on both of these points, but I'm happy to do
Oh.
that whenever you want.
Okay, please do.
So I don't think we should add mandatory reauthentication. As I understand it, you have optional reauthentication with these are orthogonal properties, and like, you know, I think you should discuss in the security considerations what the implications are and say you might want to do it and leave it at that. There's no reason to like that the must isn't doing any is like people can do things or not do things as they please, right? And make and it still adds value if they don't have that. As we've been discussing. This T thing is a complete red herring. Like it's one word in like in the text, and all the text and the text is just changed to say that like sometimes the things are in secure storage designs are not, and they could be a bunch of different kinds of secure storage, and T is a fine example of that. And we don't need to explain why the application keys are not in the T. Like that's just not like relevant at this point. It's like that text can be changed easily, but it doesn't need to have T doesn't disappear. Doesn't need to be discussion of T's. So I think all these things can be solved with just like some editorial work.
Excellent. Thank you very much for supporting author's position. John.
I mean, it may be the case, but I haven't read the documents, or maybe actual technical issues, but these are not them as far as I can tell.
Thanks.
Yeah, on the first point, I don't think you need to add mandatory built-in re-authentication. I think it could be optional, but I think you should add built-in re-authentication. Today, there is no built-in re-authentication. That means you need to change the application layer. And my understanding, the benefits of this draft is that you don't have to change the application layer. Otherwise, like if you follow NIST requirements for IPsec, it's like ephemeral Diffie-Hellman after a few hours. I don't remember 6-4, something like that. And then re-authentication after 24 hours. So then you just delay the connection lifetime if you don't have that. Yeah.
Thank you.
Yeah, Sama. Basically, I want to elaborate on the point that I have been trying to make in this TE thing. The point is that I'm saying that I'm perfectly fine if you completely remove TE. That's what I also commented on. If you completely remove everything which implies that the TE is being used, because in my head, I cannot just kind of digest that why use TE just for the purpose of storing that long-term key. if all the keys are available to the adversary at all times, like the application traffic key with which you are sending your real secrets, so that doesn't make any sense to me. So if you remove T completely from the draft, that's perfectly fine for me.
Okay, thank you.
I guess I don't really care whether TE is in here, but I think that analysis is just wrong. Like, there's a perfectly reasonable reason to have like the keys in secure storage, so if the software is compromised, they can't be exfiltrated, even if they're in Oracle, which is the usual procedure when you have the thing in HSMs or whatever. And so like normally you put them in HSM or TPM, and all it can really do is signing. And like a T can do much more, but you can make a T be like a weak ass HSM by basically having it be a signing Oracle, and that's all this test is implying. So I think that's perfectly fine.
Thank you. Yes, we have one more.
Yeah, hi, Felix Linker. One question on your models. You said you have spin promeller models. What did you try to evaluate with them?
Hannes, I think that's a question for you, if you're here.
Yeah, so the reason why I did those was specifically earlier in the discussions with David Benjamin on the comments he had for DTLS 1.3. I was specifically focusing on any detecting deadlocks, specifically when doing multiple of the different post handshake authentication messages together with message loss and all of that. So that there's a lot flying around. So I thought it would be useful to do that type of analysis.
Cool, thanks.
All right,
Okay.
thanks.
Thank you. Sorry for running over.
No worries. It's a working group draft. It gets precedent. So you guys are going to go ahead and make some changes. I guess we should make sure to update the issues to note that they were discussed and how they're going to get resolved or not. Joe, for the next, can you go ahead and start it? I also want to start a show of hands poll for the drafts that are not working group adopted yet. Just curious to see who's read them. So, you know, Yars or you can start talking about the draft and we'll fill these out and stop it at some time in the future. So sorry, Valerie, I forgot he was presenting. Go ahead.
Is this the right one?
Yeah. Yes. All right, Valerie. Sorry. Go ahead, you're up. I'll give the clicker the thing so you can, yeah, you got it. All right, great.
So hello, I'm Valery Smyslov. So it seems that not many people read the draft, so perhaps it will be fun for you, this presentation. This is TLS 1.3 handshake, and it's just copy-pasted from RFC. And you can see that first message that is sent by client hello, server respond with server hello, and these messages has both have a hard-coded limit on the size of the internal structures. So the size of the message, handshake message itself is pretty large, so it's about 16 megabytes, but the size of each extension inside client hello and server hello, and the total size of all extensions is these messages is limited to 64 kilobytes, minus 1 byte. Well, it's hard-coded. And you can see this in the structures copy-pasted from RFC. So, and what if we need more space? Well, this is actually, it is the most important slide in the whole presentation. So please, when you make comment, don't tell us that this is not needed, because we're not discussing whether it is needed, whether it is not needed. Don't comment along the lines as I don't need it, or my company doesn't need it. Nobody in TLS is not needed, so it was never needed. So just imagine that perhaps it's your nightmare dream, but you have to implement it. So let's focus of how it can be implemented in TLS 1.3 with a less disturbing way. That's the point. And so the immediate goal, the most obvious goal is large caches, but we do not want to focus on large caches, despite that most of things that were meant classic MacLease and something like this. The better to have a generic solution, because we don't know what happens in the future. Perhaps we will need more space. So let's better be prepared. Let's focus on how this can be accomplished and not focus on whether it is needed or not. So we have 3 proposals in the draft. So the first is a very simple proposal, just extend client hello and server hello, make some changes in the cache structure. This proposal is very focused on caches. It was initial proposals in the draft. So it's focused only on caches. So caches, some more complex structures that its size depends on whether it proposes already defined algorithms or new CAMs that have a bigger size. And for the bigger size, it just have a size 16 megabytes in power 24-1. And so the same as for extensions as a whole, as a list. So this is very simple proposal, very simple change. There is a proof of concept implementation made by Jonathan, and it just works. It's fork from OpenSSL, I think. So it doesn't change TLS state machine. It's good. So no additional route trips. If server supports this extension, it's also good. But the main drawback is that it is not backward compatible. So the client need to know beforehand that server supports this extension, because otherwise it doesn't work at all. So it might be okay for closed environment, but not so okay for open internet, or perhaps not the internet, but more open networks. And yes, it is only for caches. It is not clear, at least for me, how it will interact with encrypted client hello. And it is not clear for me how it will interact with middle boxes, because I was told numerous number of times by TLS people that middle boxes are very important and they do their job, that nobody knows in details what they're doing. They might drop anything. So they do the packet inspection and see if everything is okay. So TLS must not change dramatically the messages to be friendly for middle boxes. So the proposal number 2, it was suggested by John Matson, just make similar to what IQ2 does. So utilize extended key update. Currently, extended key update only allows you to make additional key exchanges for the already negotiated key exchange algorithms. And this is possible to extend this, just negotiate additional key exchange. And in this case, we can do extended key update immediately after initial handshake with a new CAM and combine both shared secret into session secret. So this looks a bit complicated. So we have initial handshake that is not changed and immediately perform an extended key update with a large key share. So there's no modification. The good thing is that there's no modification for handshake messages at all. So no problem with middle boxes, because, well, extended key update, encrypted messages, the middle boxes don't know what's happening inside. And it's backward compatible. But the drawbacks is that TLS state machine becomes extremely complex. And while it's, as previous, as some mentioned, extended key updates, perhaps there are some security considerations with this. And we change the way that initial shared secret, initial session secrets are computed. So it's a very complex solution. And it's also applicable on the caches. That's not good. And again, for me, it's not clear how it will interact with extended key update if we want both in and out TLS to perform this this kind of trick with additional key exchange. So a third proposal, just define new handshake message. So let's define a new message, call it auth handshake data that will come right after client hello or server hello. It will contain some chunks of data that are big enough to not to fit into client hello or server hello. So its presence can be negotiated with hello return request. And in this case, for example, in case if this message is used for caches, these chunks will contain a large cache, and cache from client hello will just reference the appropriate chunk in this message. So client hello will not contain cache itself. It will contain a reference to the message that will follow client hello that will contain the cache itself. So that's the diagram, how it can go. Well, it's a generic solution. It's a good idea. It's a good thing. So not only for cache, but for anything. It's no modification to client hello and server hello messages. So middle boxes, well, hopefully it will simplify interaction with ECH. And middle boxes that look only into client hello, server hello, and hopefully will ignore a new message. I hope it can be well a good thing, but I don't know for middle boxes. It's not completely clear what they're doing, but it is backward compatible. And the problem is we always retry hello retry request, and well, but perhaps it's not a big problem. So that's all in the draft, and there are already one proposal from Eric on the list, and we don't ask for adoption at this point, just to collect an opinion how this can be done in the less destructive way for TLS 1.3. So, any comments? Yaroslav?
Right. So I think that the best approach is to do this kind of thing post handshake. So you keep original handshake as it is. You do negotiate X2519 MLCam, whatever. You indicate with TLS flag or some extension that you support this kind of thing, and then in post handshake message, a brand new shiny post handshake message, some kind of extension to extended key update message, you do an additional exchange with whatever you need to happen. That way it would be most compatible with all sorts of weird things that might be in line.
Yes, we also think that it's compatible. The problem is that it's a bit complex. And it's not clear for me after listening to Tom's presentation how cryptographer will like this approach. But anyway, okay, thank you. Eric?
Yeah, I mean, so per my review and echoing David Benjamin in the chat, I think this is an interesting intellectual problem and one we should not try to solve. The entire motivation for this, the only real motivation for this is a bunch of giant PQ algorithms with giant keys, and I've not heard any motivation we really should do that. So I think this is an interesting problem, but I think we probably shouldn't try to solve it until we're actually ready to, until we actually have a motivating use case. It is going to be quite disruptive. All of these things are disruptive. So I think we should just say this is an interesting design study and put it on the shelf for a while.
Well, I asked not to comment of whether we should or we should not. That's how.
But I mean, what is the point of this discussion then?
Let's imagine this problem is
no, but why? No,
let's
the question is, how should the working group spend its time? The working group should not spend its time solving problems that don't exist.
Okay. Perhaps imagine you have a dream, a nightmare dream that you have to implement it. How would you do it?
But as I said, we have some design studies, but now you're asking to spend working group time and trying to solve the problem. And I'm telling you that I don't think it's going to use working group time.
Well, okay.
Fair enough. So I guess the other backstory here is that this draft did originally go to the ISE, and the ISE came to the chairs, and we said, well, can't do that. You need to come and talk to the TLS working group. So I just want to put that out there.
Okay.
Okay, but not everything is suitable for adoption in this working group. And so like,
Yes.
like people should, I mean, like things come here and like people are interested or not. And so like, I'm saying we should not do it. Like if other people want to do it, there's support for it, then like, let's have that conversation. But I don't see anybody getting to the mic to say they want to do it. So I think that's like your answer.
Okay. Thank you. I got you.
Okay, thanks. We'll take it to the list. Next is, I believe, Usama.
Right, should I start?
Yeah, you should have control of the slides and all.
Yeah, okay, I got it. Perfect. Thanks. Thanks to the chairs for this opportunity. And I want to talk about some of the issues that we have from the formal analysis side specifically, and some proposals that we propose that would help things move on towards better cooperation. Starting from genomics and health data, where GF4GH is most interested in. Of course, there are other applications. I'm not specifically saying that that's the only application, but formal analysis is really a natural fit because there are high stringent requirements there, and formal analysis can really help there. And it's easy to start at the beginning rather than at the end. For example, if you find something at the working group last call that, hey, actually this was missed over and this threat model doesn't even make sense at all, that's quite late in the process. And that's where we propose that the formal analysis be done as early as possible. And the scope of this specific document specifically is focused on only and only those documents which need formal analysis. And now this will be a kind of a circular argument, which is that, okay, so which documents actually need formal analysis? But I actually here want to say that this is, I'm not, like the last time I presented this, the argument was that, hey, we actually don't need this for all the documents. That's what I'm saying here, only that it's not meant to be for all the documents of the working group. So just keep that in mind. So which ones need formal analysis is an open question, and that will come at the end. So the main idea here is that we want open source, reproducible and extendable proofs. So if there is some extension of that, some specific mechanisms in the future, for example, then the same proofs can be utilized as is and then can be extended over. So that's the whole idea, that we reuse these things rather than just building from scratch each time. I have three specific points, which are namely best practices template for authors. That's what we propose. And secondly, the proposed fact tracking process for the chairs. And thirdly, I have a few proposals. Some of them are modest, some of them are not modest. I will explain what that means. And I will use the term verifier, and I want to really clarify that it's not a gatekeeper, as Tom already mentioned. So we are presenting our, let's say, goodwill efforts for what is best security considerations. And the working group itself is like able to take that or to drop that or even trash that, whatever you want to do with that. And it's also not a role in the working group process, so to say. That's basically we being also a member of the working group as a contributor. And I'm using it as, for the lack of the good terminology, I'm just using this word verifier as the team, as a shorthand for the team doing the formal analysis. And as a supporting point, as I said, so for 8773 BIS, even after 2 working group last calls, even after going through the FAT process, they didn't detect this change, which was that the key schedule itself was not correct. And this is really the kind of the support that we need from the authors. For example, if we propose something that is discussed and accepted, acknowledged, and merged. So that's we really want to acknowledge the cooperation from Russ in this, that he really acted in a let's say a prompt manner and merged it within a week. That's ideally what we would like to see. So how authors can help us to help them, that's basically the point here. And I specifically want to say that we have 4 basic requests for the authors, namely the motivation, which is very critical. If you are doing something without motivation, that's itself questionable, like independent of all the formal analysis and all these kind of things. Like if we are spending over working group energy for something which does not need to be done at all, that's itself questionable. So we have compelling, we would like to see some compelling arguments and some authentic references that people have actually done something on top, or this is a direction which one would like to see being integrated into the TLS protocol. Secondly, a realistic threat model. There has been a lot of discussion on the extended key update right now. You have already seen that. So from TE perspective, it doesn't make any sense to me at all. Like this is something that needs to be done early on or fixed early on. Informal desired security goals, like I think every author can at least give us some kind of starting point for, and we are not asking them formal, so that's specifically the informal desired security goals, what they expect to get out of the whole draft, what they are writing, or what they expect to get out of that. So slowly we can merge them into, or if we can transform them into something which will be more of what the mechanism in the draft actually achieves and how far that is achievable and so on. And we propose 2 kind of diagrams, which are the protocol diagram, which will show like, hey, this is the client, this is the server, which messages are being sent over and what is happening on. And then the key schedule diagram, if there are any changes compared to the RFC 98462B. So another thing for the template, which is something we have, which very much follows the pattern of what we would like to see, which is non-binding and non-normative, which means that you don't necessarily have to follow that, but we would like to see that happening, which is because of the reason that it makes things very, very clear. If you have introduction and terminology and then motivation based on these terminology, you could have this motivation already in the introduction itself, but there are sometimes some terms which are very specific, and then it's better to have it like this. So we have no opinion on that. What we are basically saying is that this is something that we would like to see happening, that all the components which are mentioned here should be part of it, and not necessarily in the same order or same pattern. But it would be very nice if we had such a pattern so that the readers, reviewers, formal analysis team, and everyone can actually see some symmetry in the documents. Protocol and key schedule diagrams go in the proposed solution. That could be 1 or more sections for that, and security considerations, specifically if you have a threat model, very clearly a section or a subsection under that would be really helpful. Your desired security goals, which we will, as I said, transform into the actual achieved security goals, and then other security implications or considerations. Of course, that will not be specifically with this name, but with some other name, just to say that these are the necessary parts of it. Coming towards the ask to the chairs, basically, I would like to see that a little bit more transparency in the process. Namely, the process has to be something like this, which I have proposed in the PR number 16, which is to say, this is, let's say, this document. This is the assigned FAT person. This is the decision email which has been sent to the mailing list, and this is the initial report. So for each of those, once they are updating for new document, they will ideally see that, oh, this is actually, so the CN email is, for example, missing, or the initial report is missing something we need to do. So this is kind of a template with which chairs can already see that, hey, this something in the process has been missing now. Or in other words, I'm volunteering to help the chairs maintain this repo. They can, of course, I'm not participating in the decisions themselves. So once they decide, they can tell me over, and I can just put it in there and share some of their workload, as I can imagine they are very busy with other stuff. So we have a separate list for the documents not reviewed. there are quite a few of those missing, but this is just a template that we have current drafts, completed drafts, drafts not reviewed by FATs, so that things are pretty much transparent, that what has gone through the FAT process, what has not, and I will come to the slide where I will say why it has not. So some of the proposals, some of the modest proposals, so to say, the process should be as transparent as possible to the working group specifically. And what that means is that working group consultation, which is already there in the process, not something that I'm cooking up. So it's already says that the decisions have to go through the working group process, working group consultation, and then information. So that's something that I would like to see happening actually, rather than just being written down. FAT review may help guide or resolve some of the contention in the controversial drafts. This is, I think, really the purpose of formal analysis, at least in my mind, to solve some of the, or to help actually resolve these contentions. That's the whole purpose of formal analysis, to give you more robust guarantees and to give you mathematically sound formal arguments, rather than just arguing from the top of the head that we see it like this and so on. Active engagement from the authors is requested. That means basically from our side that if the authors are not responding at all to our questions within a reasonable time frame, let's say a few weeks, if not months, so that would mean that we could not just pursue their drafts. So we are not at all, just like the draft authors are voluntary service, so we are as well. So we are not bound to any specific draft to lead it to completion, even if we have started the work on it. So for that, from our side, it's also already a loss. I mean, we spent some effort, we cannot publish it and so on. So it's already a loss for us, but that would be very unfortunate from our side as well. Some not so modest proposals, meaning that we have quite a bit of a strong opinion on this, which means that, first of all, the TLS working group needs to encourage early consultation for other working groups, specifically where the working groups do not have a TLS working group participant majority. And in that case, for example, like seat working group, and in that case, if they are going through such major changes, which is that what we have agreed upon them for the chartering, and if they want to recharter and make these changes to the TLS protocol or the key schedule or whatever is explicitly allowed in their charter, there has to be early consultation process with which they can go through. And secondly, I really have very strong resistance against the process which is saying that you cannot contact FAT directly. I mean, if I was doing the same draft of the TLS working group and I was not a member of the TLS working group, I could just contact them, hey, XYZ, I have come through this and I need your help in this. So this is really something that is really limiting our abilities to work positively by not just contacting them. This is not the way it should happen. Like, it should be encouraged. We are fine to have the chairs in CC for that if there is any concerns on that. But the formal methods community is really small. We have limited folks with knowledge of TLS. Like, who else do we contact? So if that's a really bottleneck for us. And the feedback we get on the list is very limited. I think there are only 2 to 3, like Ecker, John, and so on, who are just responding to it from the formal perspective, which is helpful for us, and not much otherwise. And specifically, the discussion that I would like to have is one is probably answered by Tom already, that the computational security analysis is not thought to be in scope for FAT. That's what at least I understood. The second point I have is which drafts need or do not need formal analysis, and why. I think the rationale has to be more clear to everyone. Tom, please go ahead.
Just quickly stepping in here, computational analysis is absolutely in scope.
Oh, that's what I heard, that you are kind of meaning from your presentation. Okay, if it's in scope, that's fine.
No, the first line in my slides said that extending the existing computational models to EKU would be a lot of work, and is not trivial, but is worth doing. And separately, analysis in a tool like Tamarin or Proverif could also be helpful to understand how that
Let me-
situation is going with EKU. So
Sure.
either are
Let
helpful.
me explain how I kind of view that. So I think I got the impression from your discussion with MLChem that you are implying that computational security analysis is not part of the FAT process. So that's what I got, not from the EKU. So I got it from MLChem. That's what you are implying,
No.
that
Analysis of cryptographic primitives, which is cryptanalysis, which is an entirely different ballgame.
okay. I see. That's out of scope.
Yes, so like cryptographic, we're not going to do like assessing the core SVP security of MLChem, but a computational analysis of so that's a pen and paper proof for sort of the non-protocol people. That is absolutely in scope.
Okay. Thanks.
Okay, guys, we're a little over, so let's keep it brief. Thanks.
Yeah, hi, Felix Linker. To your second question, I mean, working group consensus seems to be a good measure for that, no? So if the working group would like to call the FAT, they can call the FAT. That seems lightweight, and I guess you need to go through that anyway, through that discussion.
So the drafts, I would quickly just expand on that. The drafts have not gone through the working group process, which means the chairs first need to bring into so the process says that the chairs make this decision, not the working group. So
Well,
there is something
but I
that needs
mean,
to be clarified in the
chairs
process.
do the calling, right? But I mean, I guess they listen to the working group, whether it's required or not.
I mean, it's gonna get fat review before it gets out the door. So
Yeah, so I think there's some material in here that is good and some that is not. I think the idea of having a dashboard and transparency of what is happening is good. I think that like the attempt to construct some sort of special role, which you say you're not doing, but that totally does for this verifier, is like quite unfortunate, and we should not do it anyway. Like, there's no reason why the like maybe the FAT should be like able to maybe people should be able to talk to FAT, or maybe it shouldn't be. But the idea that like some people should be and some people should not be, very unfortunate. We should not do that.
Wait. So I can a little bit slowly. So what you are saying is basically that, are you in support of contacting the FAT or not?
I'm saying this last bullet is bad. Like maybe it should be the case that the FAT should actually have like an open mailing list that people should be able to email, but the idea that like only verifiers should be up on the list, that's like bad news. Like that's not like, that creates even more weird structures. Similarly, I think that like this first bullet actually also not very good. Like I don't really want to expand, like we have enough trouble getting like attention for things that are actually important to TLS. Having the whole purpose of having like these other working groups is like TLS doesn't have to engage with them. So like I think trying to like turn that into something that where TLS is a new obligation is also bad news. So I think like my short version is I think that like the transparency part is good. The rest of it I think less good.
Okay, I will quickly respond to it if chairs allow me. Shwan, is that
sure,
good
you got a
for you?
minute.
Okay, so for the first point, I would say it's not going to happen daily on daily basis, right? So it would be very rare case. So we just need to make a very small process that if you need to make some prominent changes of what we have allowed you in the charter, just this is the process. Come to the chairs, talk to the chairs, and chairs will do whatever is needed. That's pretty much it. So it's not going to happen daily basis. I don't think it will take any of the working group energy. On the second point, I strongly disagree with you. I think that might not even be interesting to the whole working group, this kind of discussion that I would like to have with the FAT. So I would say it may not be interesting for them to have, and from the FAT perspective itself, they would not like to have like getting like 100 emails from the mailing list that, okay, so this person is saying this is saying this, and how would they keep track of this? I think this will increase a lot of burden for them. The thing to do is that maybe a limited people from the working group may be involved in that, but I wouldn't open it over to a mailing list which is open for everyone. So that could be a very small design team. But I really have a concern that we are really facing this problem, that who actually we talk to and how do we get these things resolved. So we need some way out for this.
Okay,
Thanks.
thanks. We're gonna move over and do some ECH talk now. Thank you very much, Joe. We got the slides up. We'll see, because you submitted an update, and we'll have to see if those are the right ones. I'm hoping they are.
How do I pass the slides?
That's a good question. You should be able. I can give
With the
you
clicker?
the plus here, and I'll give you control, and you should be able to. Oh no, that's the wrong one, Joe. It's
Oh, is that the wrong-
ECH. Yeah, it's ECH measurements.
Each measurements. Yeah. Thanks for accommodating.
No worries. So you should be able to have the slide. Can you see the thing there? Hold on, let me make
It's
sure.
the wrong one.
It's the wrong one. Let's see if it comes back. I got the button ready to go. All right. Yes, I'm going to give you control. You got it?
Yeah.
Should be along the bottom.
I think so.
There we go.
Along the bottom. Is this moving? Okay,
Looks good.
I think I got it. All right, thank you. So yeah, let's talk about ECH and HTTPS resource record. So I want to see that implemented in the various libraries, but like library developers have this question, like, is it safe to enable those things by default? You don't want to break connectivity or negatively affect performance. So that's like has been a common question, and we need to answer those questions so that we can actually have it enabled by default. We don't want this kind of thing to be opt-in. We at worst it should be like opt-out. So is this safe? So we did a series of tests to try to answer some of these questions, like how does waiting for the HTTPS resource record affect performance and connectivity? Performance here is really like latency. And the other one is, does enabling ECH by default break connectivity? Like, do the services break when they don't support ECH and get like a grease, ECH grease? Or also, do networks block ECH? That can be a problem too. And those are things that have been in the mind of library developers. So let's start with the DNS tests that we ran. So the DNS test was pretty much for HTTPS resource record. We were querying the top 10,000 Tranco domains, that domains from the Tranco list, which tries to get like the top domains. And we queried the Quad A, and HTTPS records. We measured the response times, did that 3 times to try to kind of mitigate variation and possibly caching too. And we plotted the distribution. We have better graphs, but like the idea here is that the performance is not very different of those records, which was a good sign. But I wanted to see it in a different way. I introduced this concept of HTTPS delay, which is the timing of the HTTPS resource record minus this happy eyeballs baseline. So the happy eyeballs baseline is when you would start the first TCP connection when you use a happy eyeballs v2. This is considering like the timing of the A and quad A and the resolution delay, which is 15 milliseconds if you get the A record first before the quad A, just to make it more reflective of the connection process. And then I got some measurement, like I plotted this HTTPS delay and the distribution, and you can see that we actually get 60% of these runs. The HTTPS record actually beat or tied the latency of the regular connection. Which is a good sign. And I can see here that at the bottom, like there were like a bunch of cases where HTTPS resource record actually arrived before you would start establishing the connection, which means that if you have IP hints, you can actually already like reduce latency in those cases. And then on the other end, when it increases latency, like the increase was small. Like 6% was more than 50 milliseconds only like 3% was more than 100 milliseconds. And when you look at distribution for, so just to be clear, this is like only the domains where the HTTPS response arrived back without an error. If you only look at the cases where the domain supports H3, they have LPN H3. So they support quick. That chart is even like more tight. And so the difference was like really minimal for those domains. And you are saving an entire round trip with quick. So it's really like a significant latency gain there, latency reduction. And one important point here is that this HTTPS delay only really becomes a penalty if it takes longer than the TCP connection. So you have like the time of the A quad A plus the TCP connection for the HTTPS record to come back, because if you get that, you can still apply you can still apply the config to the connection that's being established if the endpoint matches, and often they will match. But then you can say like, oh, this TCP connection, I actually want to use H2. Or if the config says H3, then you can wait for the connection, but you can also just go and start the H3 connection, which saves you a round trip too. So essentially here, the point is the HTTPS resource record will only really give you a penalty if it's slower than the other records by more than a round trip here for like the TCP handshake. So should we wait for HTTPS resource records? So like there's no, or like small latency penalty, you can actually reduce latency by avoiding the TCP round trip if you use quick, and you can also reduce by using AP hints. However, there are like some very significant domains that do not respond to the HTTPS resource record. So like you can wait as much as you want. You're not getting the answer. They would just like time out, and that's a problem because you just can't wait. In those cases, you're gonna like run into the application timeout. So we need to fix those domains. I don't know if people have contacts like the .gov domain in the US. That's very problematic. Like a bunch of domains under that .gov is just not responding to HTTPS. And I've tried to hit the authoritatives directly, and it still doesn't work. So we need to get those domains fixed. So because of that, just because of these domains, I would say that the recommendation here is to not cap, like you have to cap the weight for those domains, but ideally you wouldn't have to. And then the domain owners should really like fix the authoritatives.
Can I ask a question actually?
Sure.
So, I mean, these authoritatives are like flat out defective, right? Because they should be NX domaining the RR,
Yeah.
right? Okay, that's what I thought. Can you send me privately this list? I may be able to reach out with these people.
That would be awesome. Yeah. Okay, moving on. ECH grease test. So
1 sec, Victor jumped in the queue too.
Just really all the contacts are published. You can on GitHub. You can download it from the DHS website if you want it. You know, there's a huge list of all of the technical contacts for that guy. If that's your concern. While I'm here, the client locale from which you were measuring this, were you in a well-connected environment, or did you try this behind various oddball, routers and hotels and all that kind of stuff?
No, I did this measurement from a residential network, and it worked fine. When I tried in a corporate network, I actually got timeouts and throttling because I think they analyze every packet but in this case, it went very well. Okay, let's move on to the ECH grease test. We want to know that whether grease will break the domains. So in this case, the test was for the top 10,000 domains in the Tranquil list. We fetched the domain, like HTTPS domain and the root path twice. Once with ECH disabled, and once with ECH enabled with grease. And in this case, we used the ECH enabled curl because there's not a lot of support for ECH grease in the libraries, which is kind of like a challenge here. So, but the DEFO team that was adding ECH to OpenSSL, they actually had a version of OpenSSL and curl that I built that allowed me to do this test. And then pretty much there were like no adverse effects. At my first run, like I saw like 26 domains that showed differences between control and experiment, various different errors. But then as I retried those domains, they succeeded. So I think they were just like transient issues. So for this top 10,000, grease didn't really break the connectivity. And some showed like different handshake time, but I don't think they were significant. It was just 2.35%, and maybe this was just like variability. I didn't run this multiple times, but because the result was alright, like they all connected. So, and then the third test that we ran was the network test, where we were testing ECH on multiple networks. We used this proxy network called SOAKs, and we iterated over all the mobile networks that they support on each country, and we tried to fetch www.google.com via the proxy. Also, again, twice, one with ECH disabled, once with ECH grease, using the same curl binary. And then we covered 878 networks in different countries. And here we only see like a 0.34% cases, only really like three networks where ECH grease failed, but no ECH succeeded. This I still need to do some more investigation and work, but like in general, it was a good sign. Those are a good chunk of networks that we were not able to properly test, like 22.9%, where both the control and the experiment failed. So that reduced our coverage, potential coverage here. And maybe it was like instability issues with the proxies or rate limits. They have those. We also saw blocking of google.com in China. So we were not able to test in the Chinese networks, but we know that in general, in China, ECH is not blocked. So those were the results. Like the conclusion here is that you should be able to enable HTTPS resource record and ECH by default in your networking libraries, but provided that you cap the HTTPS resource record for now until those like top broken domains are fixed. And we already have the tools at this repository on GitHub to collect the data, so you can reproduce this test yourself. That would be great if other people do that. And the reports are not there yet because we are working on cleaning up the Python notebooks. But we should have the analysis there too in the next couple weeks. So that's it for me. Hopefully we'll see more implementations of ECH and the HTTPS resource record out there.
Yeah, no, so this is great. So I don't know if anybody else wants to jump in. I think this is encouraging results. The world is not falling. I think this actually would be pretty interesting because I know there was an ops document that was being written to say lots of interesting things about ECH. So I don't know what other people need to, if anybody else wants to get in and say anything, or other than just say thanks for doing all the hard work and doing these measurements.
Oh,
Victor?
Just some resources for DNS measurements. The Atlas network is generally fairly useful. It's a vast network of probes through which you can proxy your DNS queries and measure how they behave across the world. So look for Atlas probes if you haven't done that. And of course, you'll want to make measurements from behind various kinds of home routers and the like, although some of those may be covered by the Atlas network, in fact. So that's a good thing. And I pasted into the chat a link for the CISA repository where you can get all the .gov contacts if you want to pursue that. You can reach out to them. I've had some interactions with a few of the government departments on some DNS topics, though not HTTPS. But
do they have the contacts information there?
Yes. Yeah, in the each line in the data contains contact information. It's essentially a CSV of all of the federal and state domains and whatever, if you need them.
Awesome.
But I'm skeptical about HTTPS being broadly available across all networks other than authoritatives which don't cooperate, because I expect more problems on the access side. Basically, the last mile is, when you're behind a very obsolete home router or a hotel or whatever, that's where I would expect to see problems more than authoritative. So even if your residential network is good, lots of others might not be. So the measurements really need to be done with care. I'm skeptical that these really cover enough ground.
Awesome. All right. Thank you very much. I'll kill this timer off. I'll start the next one. I also started a poll, a show of hands to see who's done this. This is another ECH related thing. Nick and Dennis and Alessandro have presented a couple times, but over to you, Dennis.
Thanks, Sean. Yep, so presenting the signed ECH draft, which is an extension to ECH. And the core goal is basically to make ECH easier to deploy. So at the moment, when you're thinking about deploying it on the server side, you need to choose an outer SNI, a cover name, which you'll need to go and register, get a valid TLS cert for, and then provision your server with. And that's the name that will appear on the wire to middle boxes and so on. And what we'd like to do is basically cut away most of that, and you can just pick an outer SNI and update your configs. You're not going to need to register a domain. You're not going to need to get a TLS cert or configure anything. And to sort of talk through how that works, ECH has a happy path where the client and server are in sync with each other and the DNS information is up to date. And in kind of regular ECH, you go to DNS, you grab an outer SNI, you grab a public key, encrypt some stuff, send it over to the server decrypts it, and you authenticate all of that with a valid TLS certificate for the inner SNI, And with signed ECH, we're not changing any part of that flow. There's a little bit of extra information we're putting in the config, but it works just the same way. So the server decrypts the extension and it's authenticated again by the TLS certificate for the inner SNI. But there's also the unhappy case, and that's when the server and the DNS record are a little bit out of sync with each other. And in that circumstance, there needs to be a recovery path. And the way that works today is the server can't decrypt the ECH extension because the config's out of date, and it will provide a fresh config and authenticate that with a valid TLS certificate for the outer SNI. And that's the bit that we'd like to change. So what we're doing instead, or what we're proposing to do, is to take a public key, a signing public key, take the hash of it, and pop that in DNS alongside the existing ECH config. And then when we do go down the retry route, we'll send back just any old TLS certificate. It could be for a default domain. It could be a completely invalid certificate. It doesn't matter. But in the encrypted extensions message, there'll be an ECH extension with the fresh config, and there'll also be the full public key that matches that hash from the DNS record, and there'll be a signature over the fresh config. And this allows us to authenticate the fallback config just the way that we authenticate the existing fallback config in ECH today. So to sort of remind you, we only authenticate the existing fallback config based on the outer SNI, and with this change, we're authenticating with the hash of a public key, but that's stored right next to the outer SNI, and they kind of enjoy the same properties. Now, in terms of why we think this is interesting, so effectively, this is a slightly different privacy model. With regular ECH, you're looking at a lot of different websites, and you want them to all coordinate to use the same kind of fixed outer SNI. With signed ECH, you can actually go in a different way and just tell everybody to use a random string, as long as they will generate it in a roughly reasonable way. And you can actually even do this on a per connection or per DNS lookup basis, because you can just change that SNI as much as you want. You don't need to register a domain or do anything else. And we think this actually makes it easier to deploy for server operators and more robust on the network. So in terms of easier to deploy, you can imagine a TLS server like Caddy or similar. Caddy, ships with ECH support out of the box, but it's not turned on server side because you need to provision it with a domain that you've got to register and various other bits and pieces. With signed ECH, Caddy could just turn on ECH server side and just switch you over to using randomized SNIs with no further problems, no further configuration needed by the user. And then on the CDN side, at the moment, ECH has this kind of fate sharing property where you're asking customers who have their own domain name, do you want to share a domain name with everybody else that might be very easily blockable? And most of them, I think, are pretty uncomfortable about that being mixed in with other sites' traffic. But if you tell them you're going to use random, unique, non-shared SNIs, and it's going to improve privacy, but not actually commingle them with other people, I think the answer might look a little different. In terms of the fragility and the robustness, today, a lot of CDNs are using just basically a fixed string for their cover name SNI, like cdn-ech.com. And there's already middle boxes all over the world, widely deployed, that just have a huge block list of SNIs. And this is very, very easy to add to. With using random SNIs, there's still ways to block this, but it's typically going to revolve around things like actively probing the site to see if it has a valid certificate for that SNI, or kind of doing your own scanning to maintain basically a list of domain IP mappings so that you can work backwards to who they might be connecting. It substantially raises the bar, but this is still like a cat and mouse game. It's not going to completely make this issue go away. It's just changing the dynamics of who can deploy it and what the economics of that deployment look like. In terms of where it is now, Nick's developed some interrupt code in Rust, Go, and C that kind of pass these configs and build them and so on. We recently sent it to the mailing list, and we got some great feedback from Ben Schwartz in particular. And I think we've got at least one more round of trimming this draft and making it shorter and simpler to go. But with that in mind, if there are questions or feedback on this approach, it would be great to hear them. Yeah, Yaroslav.
So first of all, I think research in this area is extremely important. Thank you very much for doing that. Yes, right now it's super easy to fingerprint based on cover name. My big concern with this approach, specifically when it comes to randomized SNI. So if you use cover SNI as just completely random string, then that is non-resolvable, you're going to have a bad day because there are cloud services that look at outer SNI and do their own DNS lookup, and they replace destination IP address with the result of that DNS lookup. They do for all sorts of performance optimization services. And there are non-trivial amount of enterprise networks that do things like destination NAT of everything towards a proxy, and then proxy figures out where it actually goes looking at host header or SNI. So I think there is at least needs to be some kind of guidance in the text saying that it cannot be just completely random string. It has to be resolvable towards where it's supposed to go. Also, again, if it's random, non-resolvable, you could fingerprint it, try to resolve it. It's non-resolvable. Okay,
yes,
looks
exactly.
like a bad thing, I'll drop it.
Yeah, so I elided that kind of detail from this, but yeah, it basically allows the operator to use whatever strategy they'd like. And yeah, giving some guidance there might be the best thing that we can do.
Hi, I think this is interesting work. I'm not sure how persuaded I am by your argument about robustness against attack, but I am persuaded by your argument about robustness against fragility. So I don't think we have to fight about the other one. I guess I'd like to hear about the trimming that is going to happen, so I can know what I should be looking for.
Yeah, I think at the moment the draft has two different authentication mechanisms in there, one built around raw public keys and one around a special type of certificate. I think the general feedback has been to cut down to just the raw public keys.
I concur with that. I think the certificate is probably not good. It seems like it's got a real chicken and egg problem. So I think the raw public key is a stronger design.
Great, thanks. Rich?
Yeah, hi. Pardon me. Hi. The shared fate, isn't that also well, when you split out and say, oh, everyone, you don't have to share fate with anybody, doesn't that also reduce the anonymity set? Or are they able to make them orthogonal?
Yeah, so what you'd be doing, right, is at the moment you're combining everybody onto one SNI, and if that SNI is blocked, everybody suffers.
Right.
With this, they're all going to be on different SNIs. Now, you could imagine a policy which sort of, tries to distinguish real from fake SNIs, and then maybe you have an issue. But you're not sharing the same fate of a particular SNI, but you are in the same anonymity set and sharing the same thing. Like if they IP block everybody, you are all still suffering.
So that if the fake SNI is resolvable, then someone will be able to go and see, oh, these are all the same. In other words, not an attacker, but a national state agency could go through and look and see that they all have the same ECH key, and that you end up sharing the same fate
they
anyway.
wouldn't see the ECH key, but what they could do, for example, is they could just scan a broad range of domains, identify those with ECH configs, and then ban all IPs associated with those. And that's something true in either draft. Yeah.
Got it. Okay, thank you. But I think this is interesting and should be keep working on it.
Thanks. I saw there was a question from Ben in chat about the stale DNS issue. I just want to quickly clarify that because I think it is important. That typically happens because you're rotating the chem key frequently, and you want to do that a lot to maintain forward secrecy. But the retry material, which is currently the outer SNI and would be the public key hash, doesn't need to change frequently. So that's why you can sort of imagine one is stale, but not the other, because you're changing it much less often. Cool. Thank you.
Victor?
What does happen when that more longer term thing is stale?
The same thing that happens when you've got a stale SNI today, which is to say you're going to get a connection error.
Okay.
Again, I'm kicking off a poll. Yaroslav, thank you. Sorry your time got cut down to the last 8 minutes here, but let's do it.
The poll is over the slides, so. Thank you. Okay, so the final presentation of IETF 125, clearly the best, the most important one, workload identifier origin hint. It was presented a few IETFs ago. There are a few updates that we've made to this draft. Basically, mutually authenticated TLS is awesome, has really nice security properties, doesn't affect application layer. It's great for bots, workloads, certain proxy setups, OTs, IoTs, but it's really not great for generic web browsers. They give user some weird UI, such as insert smart card, and users have no idea how they are supposed to react to that. So what ended up happening is people who want to use MTLS, they just have to create a separate endpoint, separate SNI that would be specific for MTLS and separate for everything else, which is unnecessary complexity. You need more certificates, and it's ugly. This applies, of course, for things such as APIs. So here is an example, relatively recent example from OpenAPI API. It also applies to things like, for example, mask proxies. So if you have some kind of connect IP proxy that you would use with workloads, you could use MTLS with that, but you cannot use the same for, let's say, web browsers, because they will freak out users. So you do need to have separate endpoints. So the proposal is in workloads, in WIMSI working group, we have this thing called WIMSI workload identifier, which is a URI. This is now adopted draft progressing in WIMSI working group. So this URI consists of 3 parts. There is scheme, authority, trust domain, and scheme specific path. So the first 2 sections are split into what I define as workload identifier origin. And these origins would be included as a list in TLS client hello extension. So this proposed TLS client hello extension contain optional list of workload identifier origins. Presence of this extension indicates that client promises not to freak out from certificate request, and client can provide a certificate for any of the listed workload identifier origins. So again, the idea is that client might have multiple, typically limited, very limited set of certificates, workload certificates to authenticate. It can give to the server hint, this is what I support. Then server may use that hint in order in other implementation specific ways to produce certificate requests with certain properties, or just maybe not accept that client hello because it doesn't like what client has to say, or just ignore it completely and not even honor that with certificate request because it doesn't know anything about those workload identifier origins. So if your workload identifier origin needs privacy, so if your trust domain is super secretive one and you don't want to expose it in clear text client hello, then maybe you should use ECH or use empty list, so that is effectively becoming a flag. You could actually combine these approaches. So you could use in your outer client hello, do empty list, and inside your encrypted client hello, you would have this list of workload identifier origins. So is there any interest in this from this working group? Are there any questions, suggestions, comments?
I guess I'm not quite tracking why you have to indicate the identity in the initial message at all, as opposed to just, I would do something or other if you ask me for a certificate.
So the reason for that, I might have multiple certificates from different trust domains, which is not uncommon. And that's a relatively small number, 2 or 3. So when I speak to a destination, I don't know which certificate am I supposed to present. And in the certificate request, if I just provide, let's say, a TLS flag in the certificate request, I could, of course, include list of CAs that I expect certificates to be trusted, but if your public API that speaks to thousands, tens of thousands of different workloads from different trust domains, that's obviously not feasible one, so that becomes a problem. That is much easier to solve from the client inside than from the server inside.
Right. Yeah. Okay. I mean, so like the ECH thing is like a pretty serious regression in terms of privacy, right? Because the ECH does not provide, like, I mean, I agree ECH encrypts the data, but like ECH is not authenticated. So it just does not provide the privacy properties that enciphering that happens in normal handshake. So like, I guess this leaves me pretty sad, I have to say.
Right. And that's a big question if robots deserve privacy or not. Let's leave that aside. But again, this is not exposing the full URI, but only the origin part, which is just scheme and trust domain, which should be relatively.
I wonder if there's some, some way to merge this with the previous presentation, and have the server supply effectively an ECH config in line, because then you could trust it, right? That is, if the server supplied an ECH config on first handshake and you had to make a reconnection, then actually you'd be in quite a strong position and you wouldn't have to worry about impersonation of the ECH via DNS. So maybe that's the answer. But I guess I'm not super jazzed about this information in what's effectively clear from the perspective of the network.
Right. Thank you, Dennis.
Yeah, just on I guess a similar theme to Eka. I was thinking more about like a TLS flag that indicates you can tolerate a certificate request as the client in a reasonable way, and then just popping out what the trust domain information goes into that certificate request, because the server can signal what it wants right at that point.
The practical problem with that is servers, especially when it's kind of public API thing that you speak to. Many clients have many potential CAs that it would trust if if CA is defined by client. So if I come and register my CA with API provider, then this is my CA that I register, and server could have tens of thousands, hundreds of thousands of them. So it's not feasible to list all of them in the certificate request. Also, they could be obviously very, very sensitive. And if I'm a workload, when I'm a client, I participate in very few trust domains, so that is feasible to present that.
But if you're a client and you're only in few trust domains, can't you just offer?
So that's what this extension is about. But when I'm presenting a certificate, I have to pick one. I cannot present multiple certificates for server to choose from in the certificate message.
But I'm saying maybe if you're only in a couple, it's okay to know which domains you should want to send those certificates to. Like, because you wouldn't want to leak that you have certificates to just the network or a general server, right? You're not going to want to provide a workload identifier on every connection.
Right. It could be certainly pre-configured, but sometimes it needs to be discoverable. That's what this is about.
Thanks.
I'm sorry, I don't see who's next.
Tiru. And we're over time, so let's keep it short.
Yeah, thanks, Yaroslav. This seems like an interesting draft. So I have two suggestions, basically. I think this draft does not discuss using trust anchor IDs, which is quite useful for the client to convey the trust anchors that it is relying on. I think you should see if you could complement with that. The second comment was, since workloads are managed entities, I think you could get the ECH configuration provided in different ways compared to how ECH is provided via DNS or other means for open internet, right? So I think there are better ways to convey ECH, which will probably help address the problem of getting the authenticated ECH, right? Unlike what happens in the internet world today, right? Because these are all managed workloads and they are all being provisioned and managed by Kubernetes, for instance, right? So I think there could be certain deployments where ECH could be done in better ways, right? And that should address the privacy aspect to some extent. Thanks.
Thank you for the comments. As of trust anchors, I'm really not sure they apply for workload client certificates. This is something that I need to look into. When it comes to ECH information propagation in workload environments, yeah, this is certainly something worth exploring, but perhaps outside of this particular draft. All right, thanks everyone.
All right, thank you very much. Have a great day. Have a great trip home. Enjoy the farewell reception.
Yep. We'll see you next time.